Okay, welcome. Can everyone hear me okay? I think we have reached capacity and we are rolling. Okay, welcome to attacking and defending Kubernetes clusters. We're going to get back to this. I know people are still trickling in. You are in the right spot if this looks familiar and you signed up on this for this particular class. And we're going to have a lot of fun. This is a super packed house and we have lots of people here to help us out. We're going to do a quick intro, and then we're going to dive right into it. We have a lot of content to cover. So, Tabby, take it.
I'm Tabitha.
I'm Jimmy.
I'm Peter.
And I'm Brad. And who are our helpers? Please raise their hands. Give them a round of applause. Thank you for helping us. Duffy, Kunal, Ian, Mike, Maya. Thank you.
All right, so let's take a moment to meet our neighbors, too. If you haven't already, nod your head, shake your hand, say hi. Kumbaya, we're gonna get to know each other for the next 84 minutes, right?
Tabby.
Welcome.
It's gonna it's going to be great.
Yeah, it is.
Yes,
This is going to be good.
Look, I feel the love here at KubeCon. All right, so we have artisanally crafted 2 scenarios to walk through step by step, a guided tour. That's the name. That's what we're going to do. But we have some important rules to follow. Okay, bring it down. Okay, all right, so we have instructions. And we're going to follow those pretty closely, right? Everything is copy-pastable. We have 0 prerequisites for this particular course. If you've never used Kube Control, Kube Cuddle, Kubectl, whatever you want to call it, we're not going to go there. That's okay. Whisper, please, when we're presenting. This is a massive room, and we just want to make sure that we're getting the information out to everybody in due time. If you need help, your first order of operation should be to look at a neighbor, right? You're sitting pretty close to somebody who has probably solved the issue, unless it's on Google's side. Then we have some Googlers in the room that we can heckle. Just kidding. If you're completely stuck, raise your hand. So that we have room monitors, Duffy and Ian and a few others, and the 4 of us will be running around like crazy to try to get everybody through these scenarios. And attack your own cluster only, please. It's not cool to jump around and try to drop 0 day and do crazy things on other people's stuff. That is really cool, but not for today, right? We put a lot of effort into getting this situated, isolated, and please respect that. And don't attack anything from your cluster either, right? We're going to be doing some fun scenarios with fake Bitcoin mining, cryptocurrency mining, pods, and things like that. Those are fake. Please don't set up your own mining rig on these clusters. That would get really expensive really fast. And please have fun. This is supposed to be a really good time. We're really honored to be here, and we want everybody to come out of this with a little more tack under their belt to go home with and learn about. So breaking down the different scenarios, just a quick rough guideline for timing. We're operating to the second probably, but for you all, here we have scenario 1. We're going to do a full guided attack and defense. We're going to put on our red hat, blue hat, and walk you through some scenarios, about 25 minutes there. And then we're going to step it up a level. We're going to go from noob to expert and take it to scenario 2, where we dive into some more detail. And then we have some bonus challenges that are self-guided, CTF-style challenges that you are going to be let loose on your cluster. And to break things, we have special flags. And then we're going to hopefully squeeze in time at the end to walk you through those bonuses as well. And that should bring us right up until the very, very end and hopefully not flow over if at all possible. So we're going to walk through, again, getting connected. And number 1, we're going to start with this lovely domain that I bought a long time ago as a project that never actually occurred, called securekubernetes.com. If you visit that, you're going to have all of the lab material necessary. So please open this in a private browsing window or incognito window. If you've ever experienced cross Google accounts, multiple Gmail accounts, corporate accounts, that's going to get messy. So just do this in either a brand new fresh browser or in an incognito window or private experience. Got that? SecureKubernetes.com. Cool. All right, so let's dive right into scenario 1. This scenario is called free compute, and we have a lot of fun to do. with this particular scenario. So if you head on over to securekubernetes.com, you can see our helpers are going out into the field, getting ready to help everybody. So if you go to securekubernetes.com, we are going to see scenario 1. And I will go there as well, and you can follow along. So here we are, securekubernetes.com. This is assuming we're all set up. So I think most of us in the room, with the number of hands and G-Cloud kind of worries we had a little earlier, hopefully those are subsiding. We were running into that too, but things do settle down, and we will get our Cloud Shell account. So we're going to get connected. So you should all have a credential card. Does anybody not have a credential card yet? We have one right here. Okay, you might be number 401 in this event, but we have some overflow, so we'll get you hooked up. Maybe, hopefully. So we're going to open Cloud Shell. So when we do that, this button, this lovely button here, is going to do some very special things for us. If you look at the URL, you can see that. But for the sake of this, we're going to open Cloud Shell, and it should look something like this, right? So we have Cloud Shell up and running. I am KubeCon 401. The naming convention is not that important. Just know that you are dropped into your own special project. We had to go through a lot of hoops to get that to work, but we're there. And then we're going to get set up. So when you have Cloud Shell open, you're going to be presented with a login page, right? This is where we're going to enter that email on the card and the password as well. If that doesn't work for some reason, again, that's a hand-up situation. Let us know. We'll get you figured out. And then we follow through the prompts. We accept our terms and conditions, simple stuff. We've all read this in great detail, I'm sure. Then select your country, United States, and you agree to the GCP terms of service. Great. Then we start Cloud Shell. So as you start Cloud Shell, we have a very special Cloud Shell setup that's going to run for you, be pulled into Cloud Shell with a lot of helper scripts and things that get you up and running really, really fast. So the key here is this command, kubectl get pods -- all namespaces. If you use Kubernetes, which most of us have, we've run this. And this is just to prove that we have connectivity to our cluster. And, skipped this last time. So setup.sh. So setup.sh is a really important script. And I'm going to run these with you. So in this secure Kubernetes page right here, you could use the copy and paste straight from here. This is the easiest way. So when I copy to clipboard, go over to my Cloud Shell, make sure everything's good, paste it in. This is setting my project ID to the one that was provided, and a couple other helpers for you to get you connected to your GKE cluster, so our Google Kubernetes Engine cluster. So we're going to let this run, and this is what will enable us to run the kubectl get pods all namespaces. And I know we're going kind of fast through this section because we really want to get to the meat of it. And anybody not have access to a Cloud Shell yet? This is just a total, okay, that's not bad. Google's catching up. That's good. That's good. That's only a few. So for now, please just work with your neighbor until your Cloud Shell comes up. I'm glad we're at critical mass with that. So here we have setup.sh that did some magic for us, right? You can go read the script if you're interested. And then we have, I'm going to copy and paste. We have our kubectl get pods all namespaces. Copy that to the clipboard. This is our test, right? This is going to show that we have pods running, right? And these pods are, some of them are used in class, some are part of the Kubernetes GKE version we're using, but something should show up here, right? If you've used Kubernetes, you're used to this. So let's press on. And that's it. We've done the getting connected step. Okay. So now we're getting more. We're getting even more helpers. I see Maya is helping out. This is awesome. So, okay. So let's dive right in. This is going to be as role-play-y as possible while still kind of breaking the fourth wall and helping people along the way. I'm going to take over scenario 1 as the attacker. I'm a newbie. Just opportunist attacker, right? And the backstory here, really quite simple. I just find automated scans. and scripts off the shelf, and I run them against vulnerable IP addresses or infrastructure, right? I don't have a lot of skill, and I have very limited Kubernetes knowledge. So this is something you'll probably be up against in your own clusters, but we want to learn kind of how this plays out for somebody who is an opportunist, right? And cryptocurrency mining is my game, right? That's my jam. I have to make rent next month, so I need to get these cryptocurrency miners installed on somebody's cluster. So Red has been mining Bitcoinero for a few months, right? So we're mining Bitcoin, and we are using a service that is selling shells for us, right? We can purchase a shell, or a friend gives us a shell that they have gone out and exploited, and we have access to that now, right? That's really cool, right? Because I don't know a whole lot about what I'm doing. And as an attacker, I'm going to utilize that shell to do some bad things. So a brief note on attack patterns, right? If you attended Ian's talk this morning, a little bit of this thinking in graphs sort of mentality was mentioned, right? So attackers think in graphs. So we're studying our target. We're doing a lot of research on what's going on, and we're actually planning our attack in great detail before we just go and throw our exploit or our code onto that target. So and if you see me skip over something in the tutorial, it's here for you all later, and we can that'll be available for you. So the key is we want to attack something, right? We want to get our payload or our cryptocurrency miner running on this vulnerable cluster. We want to persist as well. That's going to come into play in scenario 2. So attack, persist, and then win. And win for us right now is straight up money, right? Cryptocurrency mining, and this is something we see very, very often in the Kubernetes space. So we are going to do some steps to get an endpoint that we have compromised already. This is a web shell that's running in the Kubernetes cluster that is your target. Your scope is your cluster, and that's it. So we're going to do this together, and we're going to run this check email script right here. So if we copy check email.sh, we're going to see some interesting things come up in our Cloud Shell. Hopefully. So, okay, this is the email from my friend that I purchased this shell from, right? So here we have an IP address, 35.236.114.113 with a special port. So when we visit this, we can actually get a web shell. So if you run check email, get your IP address with your port, and click on that as a URL, you're going to be presented with this HTTP basic auth login screen, right? So this is where we need to enter credentials. These credentials will match what's on here. This is not something an attacker may go through typically. This is to protect our Google billing account from being completely and utterly owned within this 90-minute time frame because only you all should have this set of credentials. So I'm going to enter KubeCon 401 at secure9.com and then define enable one. So, a web shell. So this is a web shell running in the browser, right? So this could be seen as an exploit, some sort of backdoor. There's a number of ways through an attacker's lens that you can get to this destination, but we're not going to go over that in great detail today. This is our foothold into the cluster. This is our entry point as an attacker, the way we have access to this cluster from the outside world. And we see this all the time out in the wild as well. So we should all be looking at a web shell like this. And if you don't, and if you're really kind of wondering where you're at, raise your hand. Everything's laid out in the tutorial in great detail. So we want to mine some Bitcoin, right? We've studied our target. We have our web shell, and we want to get some loot, right? So as an attacker, the very first step is not just throwing a script that's going to go mine Bitcoin into this environment. We have to learn a little bit about it. So here we have a list of common commands we can run once we're dropped into a shell, right? We don't know what user we are. We don't know what group we're in. We don't know if we're on a VM or on a container in Kubernetes in whatever, right? So we got to do some background check, right? So we have to check out where we're at. So we run commands like ID, right? I'm going to copy that to the clipboard, and I'm not going to go through all these. And these commands at this part of the walkthrough, these commands are run in this web shell in the browser. So ID, right? But who could tell me what I'm looking at now? UID 1000 dashboard. Am I root? No, not root. Okay, that's interesting, right? So I'm going to run, let's do ps-ef. Huh, what's this? What's ps-ef? Anybody have a guess? Process? Is this typical of a virtual machine or a container? Probably a container. There's not that many processes running, right? So that's interesting, right? And as an attacker, I'm writing this stuff down, right? Step by step by step. So as I go down my list, and we can run more and more commands if we so wish, but we're going to keep digging in, right? So one of the main ones here I want to run, I'm going to bring in a tool from somebody else, right? I think this is Jess Frizzell's tool, right? Am I contained? I want to curl this using the curl utility, which is going to go download this file onto my shell. Well, I think it's a container. I hope it's a container. And it's going to tell me a bunch of information about the space I'm in, right? The space I'm operating as. So I copy this curl command, and I'm going to pull this down. And I see a bunch of interesting things. And for the sake of not going through every single syscall and things like that, there's an interesting piece here. Container runtime is Kube, right? What is that? What does that tell me as an attacker? Probably running in a container inside of Kubernetes, right? Well, we are at KubeCon, so that's a given. But this is the process, right? I know I'm in Kubernetes, so I have just reset my expectations, reset my scope, and I'm just going to throw away all the things that don't pertain to Kubernetes because I need to get this thing running ASAP. So I'm going to go back to my scenario. And now I know that I'm in Kubernetes. I'm going to run some very specific Kubernetes commands. And I suggest, I'm kind of blabbing and talking up here, but I suggest you run the commands I'm skipping over as well to kind of get a feel for what that looks like as well. So I'm going to look at my environment variables, and I'm going to look for the word kube. And when I do that, interesting, right? Those of us who administer Kubernetes clusters have seen these things. Kubernetes ports, IP addresses, and all sorts of interesting internal IP address space that is running Kubernetes, right? So I'm going to log that and put that in my memory and in my notebook, right, as part of my attack. And then I'm going to look at the version. This is a really interesting one. So this command is going to give me one special thing, right? Get version. This is version 1.13.11-GKE.14. I'm running in Kubernetes, but I'm also running on GKE. That narrows my attack surface even more, right? If I know there's a GKE exploit, which there, of course, would never be one, right? Then I'm going to target that, right? If I know the Kubernetes version, I'm going to the CVE list, and I'm going to check and see if there's anything out there in the wild that I can exploit, right? This is really, really, really useful stuff. So I'm going to keep digging in and see what I can do on the actual machine, right? So to do that, I want to interact with the API server. And how do we interact with the API server in this context? What tool do we typically want to use? Kube control, right? That's what or kubectl, I don't know. This is a tough crowd with how to pronounce that. So I'm going to copy this, and I'm going to go grab kube control. This is going to install the kube control binary onto. It's already installed because this is our testing cluster. But we're going to have kube control installed onto our running container that's in a pod that's on our GKE cluster. With that comes a lot of power, right? We have kube control. And we can start to test out permissions and see what we can actually provision onto the cluster. So once kube control is installed, I'm just going to go down the list, right? I'm going to go to do a kube control get all. This is a great nifty little command. What can I see, right, as this user with this service account? So here we have a pretty comprehensive list. We have replica sets, deployments, services, et cetera. And we have the running applications. And now I want to get namespaces. So I'm going to run kube control get namespaces. Interesting. I'm forbidden. I'm not allowed to run this command. What's going on here, right? So namespaces is forbidden for user system service account PRD default. So this is saying there exists a PRD namespace, and I don't have access to go get a list of all the namespaces running in this particular cluster. So that's really interesting. I need to elevate my privileges or figure out something else to do, right? If I want to see everything. So, kind of throwing it back to this kube off can I from a little earlier today. If you've been around, this is all the attackers love this tool. This is going to just tell me straight up what can I do, right? The real thing is I want to create a pod. At the end of the day, I want to get my own workload running on this cluster. I need to make money. I don't care about how elite I am. I just need to get things rolling. So I want to use kube off can I create pods. So I'm going to copy this command and yes, right? That's really all I care about to mine cryptocurrency as my unskilled self, right? So I'm going to go create a pod. And if you're privy to this, you probably noticed this is already running, but that's okay. And in this section here, this is my Bitcoin Arrow cryptocurrency mining deployment. I know I can create pods. I have this running web shell. I have access to this cluster. I might not be cluster admin, but that doesn't matter for me right now, right? I want to do some damage and utilize these resources to mine my cryptocurrency. So I'm going to copy this command, which is just YAML, and it's going to go create this deployment called Bitcoin Arrow. Paste that in, and magic's going to happen. Okay. Okay, so here I have my Bitcoin Arrow pod running. This is a test cluster, so working on the fly. Okay, I'm going to recreate it now. So this is what you will see. So I'm going to recreate my deployment, and I have my Bitcoin mining infrastructure up and running in this Kubernetes cluster, right? Here we have, should be somewhere. Maybe it's not up yet. Okay. So to pass this on along to my defensive counterpart, as far as the script kiddie is concerned, I'm already mining cryptocurrency in this cluster using my Bitcoin Arrow deployment, right? This is running. It's not sophisticated. I got it from the internet, but it's getting the job done, right? So hopefully you were able to follow step by step, and now we're going to talk a little bit about the defensive tactics as part of this walkthrough to my lovely counterpart, Brad.
Okay. So hi, my name is Blue, and I'm an overworked sysadmin. Oh, whoa, what's that? Hold on. What time is it? Hey, yeah, boss. Oh, the website's slow, got it. Which website? You don't know, okay. You know it's 1 a.m., right? Oh, okay, I'll get right on it. Life of a sysadmin, huh? Okay. Generally speaking, I can only do the bare minimum. There's only one of me, so this is kind of how I roll, and this is just par for the course. But we'll see what we can do, because I'm pretty confident we're doing everything right, but we'll see. So without a lot of details, I sort of have to figure out which cluster, which deployment, what's going on. Like, why is this slow? So we're going to switch gears here. So take off your red hat, put on your blue hat. We are going to be using the same cloud shell as the administrator at this point. Okay, so now you're switching into the administrator. You fire up cloud shell. You have your credentials to the cluster. So follow along in this sense. So I'm going to run kube control get pods all namespaces. I'm going to do one more zoom. That's too many. Okay. I am in the web shell, not in the cloud shell. See? Don't follow that. What I'm going to do is zoom this in a little bit. And you can do this too if your eyes are like mine. Okay. Get pods all namespaces. All right, so I'm the sysadmin now. And what I'm looking for here on the left is the running. Now it's on the right. Okay, looks good. Everything looks good. It's running. This cluster doesn't look bad from any, there's no crash looping pods. What else is next? Well, they said it was performance related. So let's use kube control top. Okay. What does kube control top do? An average of the last little bit of, let's see, did Jimmy, we're going to do this again. So we get Bitcoin arrow. Bitcoin arrow didn't run. Okay. Okay, 1 second. Pause the blue scenario here in your heads. And we're going to go back. Get this here, Doc. There we go. It might still be there. I'm just going to paste it in anyway. Is this put in the default namespace? Tell me that. Nope. Bitcoin error should be right here. Okay. Yeah, no kidding. Delete. I don't have, there we go. Interesting. I know what to do. I found it. Here, hold on a second. No, we have something else at play here that I don't want to let you know about until later. Okay, hold on a second. Yeah, you found that out, huh? Stress NG. Excellent. What is stress NG?
Stress causes CPU stress.
It is our, Stress NG is a CPU stressor. It stresses a bunch of different things, but CTL delete, and there we go. Avert your eyes. This may or may not be part of a bonus bypass. That's a clue for you. Okay, that's why it's not running. Anybody tell me what's running that's blocking? Shout it out. Say it louder. OPA gatekeeper. So that's why we're creating the deployment, but it didn't show up as a pod, right? Okay. Okay, so let me go back and re-attack. Oh, there it is. Okay, great. Moving on. Back in blue shoes. Okay. So this top pod, sorry, that's where we're back at. What we're looking at here, and while we're purposely not stressing these nodes too much, is a deployment that's using a bit more CPU than the rest. So it does stick out, right? So that's a little suspicious. And I'm not really sure what the image might look like from where that's coming from. So how many of you have run this command to get pods all namespaces, looking for just the image, and then you trade the space for a new line, and then you sort unique? What is this going to give us? A list of all the unique images currently running in the cluster. So we can see Bitcoin Arrow latest is still showing up here. It still kind of looks out of place in this sense, just by its name, but it's coming from a random registry. So what we want to do is copy this, if you're following along, copy this into your buffer. This is a stack driver filter, and then we're going to open this link in a new tab. Now, I'm already in incognito. You might need to do in incognito if you want to. I'm going to move this over here. I'm going to kill this shell. Now go to the right-hand side, convert to advanced filter, select all, replace. And this is going to look at the Kubernetes cluster logs, so RBAC logs, and looking for permission for deployments create in the last hour. Okay, so there were two. As you saw, I created it and then deleted it, created and deleted it. So what I wanted to look at was who created this? The prod default service account and the prod namespace. That's kind of weird. A service account created this. That's not a human. It didn't say my name at. It said a service account. So I want to sort of see, okay, tell me all the deployments or pods that are running with the default service account in the prod namespace. Now this is a one-liner you can parse later, but basically it's JSON path and we're looping through looking for the service account name default, list it, and its service account name. A lot of these commands are very dense, and we're not going to explain every single thing, but the intent is this website is public. If you want to go run these at home, most of these are fairly safe to play with. Just do it on a test cluster, please. So we can see Bitcoin Arrow did show up here. It is running as default. Okay, that looks weird. Okay, 4 minutes ago, so that was recent. Somebody just attacked us, didn't they? We don't really know, though, for sure. So let's go ahead and get rid of this. Now, they're telling me that Bitcoin Arrow, so I texted the developers, they have no idea what Bitcoin Arrow is, so I'm going to go ahead and delete that deployment. Nobody's probably going to fess up to it either, and that's probably another problem here. Now, the other thing, oh, wait. They said that they left a dashboard node port service on prod. Okay, so we'll delete that too. That's kind of weird. Why would they let external access to a dashboard directly in the cluster? That kind of seems suspicious, but we'll get rid of that. Now, I don't know who did this. I don't have a lot of visibility of exactly what happened. I can see the service account, when it happened, where it came from, but actually physically which person or user did this. So what I'm going to do is run a deployment that we have that is a Falco installation. Anybody who is running Falco in their own clusters? Anybody heard of Falco but is not yet running Falco? Well, if you have Cloud Shell today, you will be running Falco for the first time. What we have packaged for you, or a lovely prominent blogger has packaged for you, is what we affectionately like to call kube control apply security YAML. And security is now installed. Give yourselves a round of applause. Hey. Hey. So being a good sysadmin, and now that it's getting like 3 a.m. in my brain here, I'm just going to check the logs. And this is getting the pod's name and then using that name because it's dynamic and then piping it through logs. Looks good. Everything looks happy. It's got loading some rules. I do briefly want to show you what the rules look like. Actually, take that back. Now that that's logging to the container logs, we want to also see that in Stackdriver. So we're going to copy that here. We're back on the advanced filter. So by now, it takes about 1 second or two, depending. Every time standard out hits for Falco, it takes about 1 or 2 seconds. It gets over to Stackdriver. So everything that's running kube control logs, those logs get sent to Stackdriver if you have the right filter. Submit the filter. Wow, looks good. Looks like we're getting some stuff, right? Security is happening. We are ready to go. Everything is happy. And I'm going to run one more command here for you. This is the Falco rules. We concatenated a few of the config map rules into one line, or sorry, one manifest. And I just want to grep through the rules for you, because this is important for what you're going to be doing later. Things like privileged containers, sensitive mounts, and disallowed containers, bash history, and those kinds of things are present. So with that, I'm going to say that that's good. I'm going to go to sleep, and everything is fine. That's what I'm going to trust, right? Okay. And now I'm going to hand it over to Tabby. Thank you.
All right, I'm glad he thinks it's all fine because I'm dark red. I'm a skilled and experienced criminal attacker, and my associate Red has contacted me because they needed some help. About a week ago, they popped a box and they put some cryptocurrency miners on it, and they were mining away, but they got themselves caught, they got themselves kicked out, and they're pretty sad about that. And so they tell me, hey, can you help out? I'll make it worth your while if you can get me back into this cluster and get my miners running again. So I'm going to go back and review my notes over here on my Linux machine, clear out the screen, and review the notes that I took from when I was looking at my associate's email. So they passed along the IP address. You can see mine here on the screen. Yours will appear on your screen. And so I did some reconnaissance on it, did some studying on it, found something that was vulnerable. So to get an idea of a little bit of what that looked like, we'll do a quick port scan on this IP address, and we'll see it looks like within this range of 100 ports anyway, it's got 3 services running. This nmap command here, this ST means do a normal TCP connection, and the A means do a lot of things to enumerate. So we see it looks like 3 web applications, 2 of cats versus dogs, which I happen to know is that company's production web app, like that's where the money comes from. But then I'm pretty interested in this one here that says dashboard, because it seems to me that if it's a dashboard, A, it's probably kind of neglected, not taken care of, not monitored closely the way the production application is, and B, it may have some kind of heightened access into something in the environment, into Kubernetes or into some kind of automation framework, in order to be able to do its dashboardy job. So you can open up these web applications in your browser, cruise around in them if you want to a little bit. But back earlier, I found this dashboard application, used some web application tools on it, found that it was based on a server-side template that had some remote code execution vulnerability in it, wrote a exploit for that vulnerability, shelled the server, and installed a web shell, just because it's a lot more convenient to log into a web shell. So we'll go now, and we will log into this web shell that I have left for myself. All right, so here I am, and whenever I catch a shell on something that I haven't been on before, there's a whole series of enumeration commands that I like to run just to get a little bit of a feeling for where we are. So I'll go into my notes, grab those, paste them in, and review the output. So it looks like I'm running as a user dashboard. It's a little disappointing. I would rather be root, but that's what privilege escalation exploits were made for. I noticed that the distribution says it's Ubuntu, but Ubuntu doesn't appear in the kernel build string. That's a little suspicious. If this were a normal Ubuntu machine, the Ubuntu would also appear in the kernel build string. And ps-ef is showing 4 processes. So certainly this is a container, because I can't imagine a VM or a physical machine that was only running 4 processes. And I see we've got some Kubernetes environment variables. All of that matches up with what my associate Red reported the problem they were having. So I feel like we're in the right place, but a little worried that there's not a lot we can do in here. So we'll do a little bit more of poking around. If it's Kubernetes, and I'm lucky, then maybe the service account that is mounted into this container will have some access on its own. You don't always get lucky, but never discount the possibility of getting lucky. Always got to check. So, like what a lot of attackers would do, I'll curl down a binary and run it. So I'm going to run kubectl get pods. I see some pods. So this is a good thing because it tells me that I have some level of Kubernetes access. But when I run get pods all namespaces, I get clapped for that. So that means I'm at least not global admin. But when I run the kubectl auth can I list, there's a lot of stuff in here. So that makes me feel pretty good, like probably I am a namespace admin. I would rather be cluster admin, but with namespace admin, at least I should be able to deploy something. So brief little aside to talk about InfoSec Twitter. There's a lot of jokes. There's a lot of silly things on InfoSec Twitter, but also there's a lot of neat tech tips. So I found a great one here on Twitter, and I'm just going to paste this right in here, and we'll look at it a bit before we run it. So this is a kubectl run command like what we'd often have, but notice that it only specifies a couple of things and then has a giant stack of overrides. And we'll talk about the 1 or 2 most important bits of this override. The first one is right here, host PID true. So normally, one of the most important isolations that you expect from a container is that your PID namespace is not the host's PID namespace. So you can only see the few PIDs that are running inside your container, and that's really why we want to think that it's contained. But when we pass host PID true in here, this container is going to be run in the host namespace. So technically speaking, it's a container, but it's a container that doesn't really have walls on the sides of it. Once we're in the host namespace, that means when we look at proc with a number, we're looking at all of the PIDs on the system. So normally we would run a command like bash or sh, but instead we're going to run this command nsenter. And that is a low-level shell interface to the Linux kernel namespace subsystem. And with this -- mount argument, we're saying we want to switch to a different mount namespace, which means a different root of which files we can see. So it feels like shroot, but it's much more fundamental and powerful than shroot. So we're going to move into a different one, because the container runtime puts us in our own private one that doesn't have anything cool. But we want to get everything cool. So what mount namespace are we going to move into? We're going to move into the same mount namespace as init is in, because that's guaranteed to be a process that exists, and we know that it's the main one of the system. So by running this nsenter with -- mount, then we can switch into the host's mount namespace. So now, if we started with a container with 4 walls, and if we took 2 of them off with host PID, we just took the other 2 walls off with nsenter. So technically speaking, we're going to be in a container, but it's a container that doesn't contain anything and is really just the host. And once we've taken all the walls off our container, then we're going to run bash. So we'll hit enter on this. It's going to run a pod, and here it is. It says root. So I don't really know. I just typed that, so maybe it's lying. But we can use some of these same enumeration commands that we would usually use in order to explore what's in our shell now. It's a lot of stuff, so that's a good sign. We'll scroll up here to the top, which is going to take a while, and we see, who are we? Root. Now that's more like what I wanted to see. Now we see a lot of release information, something Chromos, so that's not the same as the Ubuntu that it was talking about before. And ps-ef, we've got hundreds of processes. This is what I expect from a VM. We're inside the host now. We just broke out of the container and rooted the host. Let's take a minute and appreciate that. Raise your hand if this is the first time you've ever broken out of a container or popped a root shell. Congratulations to all of you. All right, so now that we're root on the host, now we can start to do something fun. So, you know, Red had this Bitcoin Arrow miner packaged up as a container because containers make running and deploying your applications easy. And, you know, that's fine and dandy, but they did it a little too easy because I think they probably just deployed it through Kubernetes, and then a Kubernetes admin saw it and deleted it. Well, I know that usually Kubernetes admins don't want to go SSHing into their nodes. That's what they have Kubernetes for. So if we have access to Docker, and we do because we're root on the host, we can just run a container right here. That's going to be a container, and it's going to be running, but it's not going to be under the management of Kubernetes. So we'll put a Docker run in here, and let's look and see, make sure it's running. That's a lot of stuff. That's too much stuff. All right, so we've got our miner running now, but it's not running in Kubernetes. It's just running in Docker on the host. So hopefully, that'll make it a little less likely that the sysadmins are going to notice us. So we could just quit now because we fulfilled our end of the promise. But this has been a lot of work for nothing but a few cryptocurrency coins that, let's face it, they're going to crash in a week or so and not be worth anything anyway. So let's see if we can do something else. I want to get some better Kubernetes creds. I'm a namespace admin, and I'm root on the host, but I would really also like to be cluster admin. So one place that we can get some creds is from the kubelet. Kubelet runs on the node. It needs to authenticate to the API server. So if we look here, It's got a kube config file, and that kube config file's got creds associated with it. So using the --kube config option to kubectl, let's try connecting to Kubernetes as if we were the kubelet and see what we can do. Can I create a pod in kube system? I like the look of that. So maybe this is going to help us out. Let's try and actually run a pod in kube system using the kubelet's creds. So we got --kube config with the path to the kubelet's kube config, and we're just going to run a busybox image. No love. And part of the reason for this is, if this had been poorly configured, the kubelet might have been cluster admin, and we would have just won the game. But in this particular instance, because it is a GKE cluster, the kubelet can create pods, but it can only create mirror pods, which are like fake metadata-only pods that represent the existence of static pods. It's a neat thing. Go read about it if you haven't, because it's lovely. But I'm not really happy, because I wanted to become cluster admin, and I'm not. So is there any other creds that we can steal? Well, we're root on the host. So if you've ever looked at the mount table on a Docker host, you see that it's crazy, because every one of your containers has many things mounted into it in order to build up the union file systems. So one of the things that we'll see in there is secrets. Secret is not a command, but grep is a command that you can use to find only the secrets. So naively, we could go through all of these files and copy out the secrets and try them. And when I was just a beginning hacker, that's the sort of thing that I would do. But since I do this professionally, I'll go into my notes, and I'll get this handy Unix one-liner that is going to search for the kube system default token, snag it automatically, and stick it into an environment variable for me. And there it is. I'll probably want to copy this for later. So let's see if this does us any good. So we can use the --token option on kubectl to authenticate using this token that we have stuffed into an environment variable. And let's see, can I get all secrets? Because if I can get all secrets, I have a good feeling that I can do whatever I want. Can I do whatever I want? Yeah. So I can do whatever I want, and that's great. But most of the time, folks are smart enough not to keep their API server on the internet. But right now, I can access it because I'm inside the cluster. I'm inside this host that's in the cluster. But I'm feeling a little worried. I want to get logged out of this web shell and disappear soon, because the longer I'm in here, the more logs I'm going to leave, and I don't want to get myself busted. So I want to be able to log into this thing over the internet, like through Tor, through VPN, through some other server that I've already taken advantage of. So I want to help myself by putting the API server on the internet. And I can do this by creating a service with a static endpoint that points to the IP address of the API server. Fortunately, professional hacker, I've got the notes all right here in my notebook. So I'll just paste that in. And Istio management. I don't know if they're running Istio, but the hope is sysadmin's looking at it and their eyes are just going to glaze right over. Istio, that's normal. So I've been a little busy. That's a thing that I probably should have done, and you'll find out later I really wish I would have. So now that we've got this token and we've got the API server exposed on the internet, I'm going to copy this token, copy it over, put it in my Linux VM, and verify that I actually have the internet-based connectivity that I think I do. Stuff my token into an environment variable. And this one-liner is just a fancy wrapper around kubectl to make it a little easier on what happens if you don't have the environment variable defined. But ultimately, it comes down to kubectl --token with the external IP in there, get pods. And so there we go. I'm in. I'm going to be able to stay in, and they don't even know I'm here. All in a day's work for an elite hacker like me.
All right. All right, so I am blue as well. Yes, I shrunk and got younger, but lost some hair. I'm still overworked, and I'm still getting paged at 3 a.m. Same message. Website is too slow. So I'm not quite sure why it's slow again. I just took care of this last time. So I'm going to start by running some basic checks. Let's get pods, see if there is Bitcoin arrow like last time. Nope, I don't see that. Well, website is slow. Let's see if any existing, let's see how is the resource consumption on our node. That looks normal. How about the resource consumption of all the pods? Let's take a look, breakdown by pods. Falco's a little high, but I don't think that would be causing a problem. That's odd. So what's going on? We installed Falco last time, and it looks like we're getting some alerts from Falco. So let's go ahead and copy this query and open Stackdriver and take a look. What kind of logs, what kind of alerts is Falco giving us? Convert to, click on the arrow on the right of the field, search field here. Convert to advanced, because we're all advanced ops people. And run. Oh, interesting. We're getting privileged container alerts, shell alerts. Let's take a look here. What's going on? In JSON payload, I see, yep, notice privileged container started. Under output fields, looks like I see a container ID and an image repository. Interesting. It's a privileged pod? I don't think that should be happening. But something happened earlier too, or later. Let's see here, yep. Same thing, output Alpine. That's interesting. Yep, and all right, so we're seeing some alerts here from Falco, but no more information. Namespace is blank, pod is blank. So I'm curious if our Kubernetes logs can give us some additional information based on what we know so far, which is just a random Alpine container that is running. So let's copy that query, open Stackdriver, switch to advanced, and in our Kubernetes cluster logs, searching for container image Alpine, looks like, yeah, that's interesting. Something got created. Something looks like, yep, there is a request to create. The request was authorized by a service account in the dev default namespace. A pod got created. That's interesting. Oh, that's not looking good, actually. Yeah. So I saw that this pod got created, but I really want to see what is going on inside this pod. So I'm going to copy that query, and I'll go back to one of my existing Cloud Shell windows, paste this query, and run it. See what's happening. What's in? Oh, wow. So we're actually capturing. That looks like someone is in this pod running commands. This is very odd, and I'm starting to get worried. What are we seeing here? There's a bunch of mounts. It looks like someone is running commands on. That's interesting. These are root, mount secret. that's not looking like something in a pod. Oh, looks like, oh, they are on, they found they escaped the pod, the container on the node. And something here about they're creating a service and endpoints. Let me see if I can see that on my Cloud Shell here.
Why is the token making it into your logs?
Why is the token making it into the logs? So all the TTY, all the standard in and standard out that the attacker was doing in the pod, in the container, was actually being captured by...
So no sanitation.
No.
The stack driver captures everything, whatever you read.
You'd want to know this.
Right. So, yeah, I'm seeing an Istio management service and endpoint. That must be one sneaky hacker trying to get back into this cluster, but joke's on them. We're not using service mesh. I am going to go ahead and delete the service. All right? Yep. All right. But I really want to know, how did they get in there in the first place? I remember seeing a create event that was authorized by a dev default service account. So something in that namespace is, let me take a look at that namespace. What are the pods? There's an app, there's a database, a dashboard. Don't tell me we have an exposed dashboard. Let me take a look at the logs. All right, let me go ahead and completion bash. Yeah, completion. Okay, I'll just copy this, see what's going on in here, and obviously, what? Really? Cloud Shell, Did something happen? Oh, it went down for a little bit? All right. Sure.
Thank you, GK. They're upgrading us for So it waited until CPU utilization was 100% and then upgraded us. We may have the autoscaler, possibly. Can you still use stack driver while this is happening?
Sure. All right, I'm just gonna take a look here.
Be back in like 2 minutes. It takes 2 minutes.
Sure. Does anyone know some good jokes? It's coming back.
Can we ask some questions while we're waiting?
Yeah, yes, please.
Can you tell me a UDP joke, but you wouldn't get it?
The joke was, I can tell you a UDP joke, but you wouldn't get it. Sorry, what was the question?
Can I get around a lot of this stuff by writing can I write a custom resource definition to be able to get around this monitoring? So, for example, have something that behaves like a pod but isn't a pod. So when you go looking for pods, you don't see a pod. Just write a custom resource definition for something, right? So it's not a pod.
He isn't here. Repeat the question.
I'll have to think about that. I'm
Yeah,
not
hit us
sure.
up after. Hit us up after. We can talk. Yeah. Try it again.
All right, we're back. All right, sorry about that. I took a look in the dev namespace, found pods that I was expecting to see, but dashboard looked interesting because I've read some headlines of some companies getting popped for exposed dashboards. So I just want to make sure that I want to find out if that's happening here. So this dashboard container does not have anything, but we have an auth proxy container in here. Looks like, oh yeah, that is how they got in. I'm seeing get web shell activity in this container with this IP address. So let's, and since they use this service account, the dev default token, what I want to do right away is revoke that token, and I might want to also consider disabling the automatic mounting of service account tokens if the pod doesn't need it. But I want to mitigate this further. The attacker was able to elevate their privileges by running a privileged container. And I heard a talk at KubeCon this week. OPA Gatekeeper can be deployed as an admission controller, which should work because an admission controller is just a piece of code that intercepts requests as they flow through the API server after the request has been authenticated and authorized. So OPA and a policy could possibly evaluate the request, make a decision, and allow or deny that request before it gets persisted in etcd. So in spirit of installing security, I'm going to go ahead and install security in this cluster. And the reason why I want to wait a little bit after applying gatekeepers, because custom resource definitions take a little bit extra time for the reconciliation loop to take its course. And now that we applied the CRD and the policies, let's actually test, see if I can run this policy actually. So I want to show you that the policies there are two policies in here. One is going to prevent any privileged container, any privileged pod, and the other one is going to only whitelist certain repos in certain namespaces. So let's see if I can just run an arbitrary container in the dev namespace now. Oh, yep. So this happens because, again, it takes a couple of seconds for the policies to kick in. So, oh. Let's try that again. Oh, still. Oh. kubectl get gatekeeper get pods. Oh. Gatekeeper. All right, we're doing some live blue ops. Get, what is it? Deploy. It's not deployment. Let's see.
So what we're going to do, there you go. So what we're going to do is while we're troubleshooting this, do me a favor and hit the Secure Kubernetes website.
Sure.
I had to run the apply twice before it took. Actually.
Okay, the field saying apply it twice if you're following along. We're going to do that in a second. I want to kickstart the bonus and then,
sure.
Okay. If you refresh, you'll see we have some bonus challenges. Okay? And we also published the hints. We're running a little bit short on time, so I want to get you started on that. If you want to take advantage of this, and if you come up, I should say, here we go. If you get both challenges, come up and whisper to us the answers of both challenges, and you'll get a fancy sticker. Okay? So there's incentive here to be able to do this by yourself. However, we will walk through at the very, very end here. But what we're going to do is we're going to flip back. So if you want to get started on that while we see if we can troubleshoot this Open Gatekeeper installation, that's what we're going to do. There you go. Sorry.
The tutorials will stay up online for everybody to use. The clusters will not. Those will be gone very, very shortly after the tutorial, so for obvious reasons.
So the question was, is this applicable to all Kubernetes clusters, like newer versions, or does this only apply to this one, 1.13? The answer is it applies to all clusters. There is nothing specific to this version of Kubernetes. Basically, privileged pods, service account mounting, stuff like that. That is just basic Kubernetes.
The environments themselves, the clusters, will be done 10 minutes after. All of the securekubernetes.com will stay up. The Git repos will be there. We'll be publishing a little more as we clean up some of the scripts, the manifests. But the actual environments, if you want to sign up for a GKE cluster yourselves, there's a $300 credit.
Okay.
That goes a long way
That
with a
works.
single node cluster like this, and you'll be able to do all these labs in the same way.
He's got it. He's got it.
All right.
Okay.
All right, and for those who want to see how Gatekeeper works in action, so yep, a second apply of the CRDs took, and when you run kubectl, run Alpine, so this is testing the whitelisting of the repos, container repos. You get the error that it's been denied by whitelisted repos rule. Also, if we want to test the creating of a privileged pod, again, so here is a here doc, and let's go ahead and apply.
Sorry, I'm standing in this shot.
And that gets blocked too. By two rules. It gets blocked because we do not allow privileged containers in the dev namespace or the prod, and because it's not in the whitelisted repos. And
Okay.
that's it.
Thank you. All right, so knowing that we have about 8 minutes left and it's a 10-minute walkthrough for the bonus challenges, and unfortunately by accident, the slightly different gray stickers, the gray border that say expert, as opposed to the white border stickers, were distributed already. So by lottery, we already have our winners picked. We do have 50 or so if you did miss one, or if you have a coworker or friend, whomever, we do have them up on stage. But I ask that you come up after we do the quick walkthrough of the bonus challenge, because I think the bonus challenges have some interesting forensics items. So we were going to give a little bit more time for you to run on your own, but I think running through the walkthrough step by step is best. Can you do me a favor? Can you do the make docs and copy them over? So that'll start in 1 minute. So if you are doing the bonus challenges on your own right now, just give me 1 more minute, and then we'll follow through. So you can do every single command, find every single part or artifact that we're looking for. So while Tabby's helping me out here by publishing these, so they're in a private repo we're copying over, making them public, I'll talk through briefly what these two challenges are. If you're leaving, that's fine. I'm going to talk over you, unfortunately, though. So what we're going to do is we're going to replay the ability to get on the root of the node, but we're going to look for some evidence of something that's already happened, maybe prior in the past. That was sort of the warm-up challenge. And then the second challenge was another artifact-driven understanding of the cluster being compromised previously, okay? So we're going to go into some Tiller artifact hunting and investigation and container forensics. So I think you'll appreciate that if you're ever wanting to look through images and what's in them without having to actually deploy the code to see what's in them. I think it's a nice little few set of steps it's worth staying for. Now, I realize it's Thursday. It's the end of the conference. It's been a long week for many of us. So if you do just want to use your eyes at this point, I think you'll still get a lot out of it. But if you really want to do it for the first time, type along with us here. Perfect. Thank you, Tabby. Looks like we're rocking. So the question was, I should go back to the question. This is the bonus challenge. So get a root shell in the cluster node and find the image name that was last run directly with Docker commands by the Kubernetes user. The Kubernetes user is specific to GK in this specific instance, but it could just be anybody. So one of the ways that we can do this that will bypass OPA Gatekeeper is we're going to run this in a different namespace. OPA Gatekeeper was only running against dev and prod namespaces, so we're going to run this against the default namespace. So we're going to clear here doc, CL apply. I need to be shorter, this helps. There we go. Okay, so we created the pod, we have applied it, we're going to exec into it, and this is yet another mechanism. I know Tabby did it with NSNer. This is the chroot or chroot method. Okay, we're still in the container, but we have a root FS. That's what we called what we're mounting to slash on the node underneath. Okay, so we're going to chroot in and run bash. That's bin bash on the node. We're not in the host namespace, but we're able to run Docker commands and we're able to look around the file system. So home Kubernetes. Oh yeah, PSEF. All sorts of good stuff. We're definitely on the node, right? And if we cat bash history, I was going to stop here and not actually run this command because I wanted to let people actually achieve it and then come up and get stickers. We still have a few left if you want to take some, but I'll show you anyway. The lovely dead beef latest image was the one that was run. So that was flag 1. Okay, so we're going to exit, exit, exit. Okay, so if you're following along, exit once, now we're back into the container. Exit twice, we're back in Cloud Shell. Part 2. Okay. It's very clear we were probably already popped, right? Multiple times over history. We were only finding the last hour or so in terms of activity. But what we've done is we removed Tiller as a deployment with Helm reset force. And what that does is that just takes the Tiller deployment out, but it leaves all of its artifacts and permissions and everything else that's associated with it still in the cluster. So where does Tiller, if it's installed in the Kube system namespace, where does Tiller leave its config maps? I just gave it away, sorry. It's in the Kube system namespace. It leaves config maps for all the versions of deployments. So these next commands are going to be extracting the Helm chart out of the remnant, like the version history, basically, the gzipped version history. So if you want to run this by yourself, that's fine. I'm going to talk through it and just do the final commands again because of the time constraints. So we're going to get the config map. I'll show that, and then we'll jump to exactly how we parse this, okay? So we can see, I should do just the config maps. We can see toned elk, version 1, right? So that was an automatically generated name for a deployment inside of Helm. That's still left over. Tiller's not running right now. So if we want to get access to what that looks like, you see all of this base 64 encoded stuff, right? This is actually a gzip of a, I think gzip tar? What are my commands? What we're going to do is we're going to find out. So we're using a little JQ. Let me scroll down. Get the config map, name tone elk, output to JSON, put it through JQ, look for the .data.release field, base 64 to code it, and then say, what kind of file is that? It's gzip compressed. Okay, so that gives us a clue of what we should do. Okay. G-unzip. Ooh, that looks interesting. It's literally everything zipped up. So you can see the templating, there's the values YAML in here. I don't think we use very many values. There's the values YAML if you're familiar with Helm charts, right? So there might be secrets or static values in there, things to ignore and Helm ignore. But really what we're looking for is this very suspicious looking image right here, okay? Should we go ahead and Docker run that? Yeah! Boo. Anybody, why would we not want to do that? Because I'm root on my Cloud Shell, that would be pretty bad. So let's inspect it gently. Just give it just massage it from the side, it's fine. Okay, so how many of you ever heard of a tool called Dive by W.A. Goodman? Dive. Excellent, wow, that's fantastic. It's a great tool. What it's gonna do, well, I'm gonna run it, and then I'm gonna tell what it's gonna do, okay? And we're actually running Dive as a container, so we don't have to install anything. But Dive, what it does is it downloads the layers, breaks them apart, and lets you view it in a ncurses-based viewer. So you can look Dockerfile line by Dockerfile line, what's going on in each line, what's added to the container to the right. You'll see. So now we're actually just looking at it and inspecting it. We're not actually executing or running it. Okay. So we can see this is from the root. It just shows the hash, so that's the base image. If we hit our down arrow, we can see we're apt-get installing curl and things. Look at the right side. Nothing's really changed in the meaningful way until we copied in our backdoor binary. It's in green. It's BD, that second line right there. And BD, I think I can tab over. That's easier to see, right? That's probably our backdoor binary, right? And then we chmod it to be executable, and that really looks interesting. Let's try and see if we can find that. We're gonna hit Control-C, okay? So we're looking, how do we find that? How do we get that out of the container image itself? What we're gonna do is we're gonna make a temp scratch space so we can extract this. So we're just making a BD temp, backdoor temp. And we're gonna run the docker save command, and we're gonna output it to a tarball. And it'll take, everybody do it all at once right now, do it, go. I'm just kidding. This is Cloud Shell, so it's gonna be quick. All right, so we've got our tarball. Still don't wanna extract it just yet, because it could be, you never know what's in a tarball until you poke at it. So tar, look at it verbosely, file. We're not actually extracting anything, right? We could see this looks like a standard container image with all of its layers. And there's 4 layers, and it's very interesting, right? Because it lines up with layer, 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 layer. We have 4 lines in our Docker file. Okay, so we're gonna extract it. Extract verbose file, XVF. We have a manifest JSON, which says what's in all of these long SHA-256 hash folders. And I'm going to jump ahead because we're right at the very end, and I just want to get to the last part here. We're going to look inside the manifest. We're going to pull out the config JSON. We're going to look at the history, and we're going to select all of the non-empty layers. So again, this looks like our Docker file again, right? So now we know what we're looking for. We're looking for probably the 3rd or the 4th layer in this list. We'll probably have that BD binary or script. So I'm just going to wing it and say, let's go for the last one. Look for the layers out of manifest JSON, tail -1. Okay, so we have that, and that's ready to go for piping into this. And here is the final flag. Extract verbose, the last layer, look at it, and then that -O says put it to standard out. This could be binary data and mess up our terminal, but we know it was 95 bytes, so it's probably a script. And there's our shell. So the second flag is 198, 51, 100, 100. Raise your hand. Has anybody followed along and gotten these flags? Give yourself a hand. And with that, thank you so much for coming. I hope you had a wonderful KubeCon from all of us. We appreciate it. Thank you.